First, exercise. So we're looking at over time and what are changes in respiration, various parameters. First, just ventilation. So if this is, I'm going to draw various things on this graph. So for ventilation, this would be like, actually, I'm going to put 0, baseline, tidal volumes of 500 milliliters. I'm going to start down here and going to go up pretty quick during exercise and stay pretty consistent across exercise time. Let's say we had recovery here. So this is recovery. Heart rate, same thing, right? You could draw that in as well. How about PO2? What do you think this does? Stays pretty flat. That's because of increased ventilation, right? There's actually not much change in PO2. It's a regulated variable. It's regulated well. PCO2. All this does depend on how vigorous your exercise is, right? We're going to have, for this one especially, we're going to have a little bit of a drop, very small. That might be bigger if you had very vigorous exercise. And you could now guess pH. So arterial pH, that's going to go slightly up and then back down. How about body temperature? Let's just do one more. Body temperature. I'm going to add it up here where there's room. And up. Why is this relevant? Well, this is helping HB unload O2. That's why our PO2 doesn't really change, right? Most hemoglobin's bound to oxygen, most oxygen's bound to hemoglobin anyways. We just need to regulate the unloading of it by having these changes in the affinity. Okay, almost forgot, I'm doing high altitude as well here. So high altitude, remember at sea level, we've got 760 millimeters of mercury of pressure from the atmosphere. If we do that times the percentage of oxygen, that's 160 millimeters of mercury. I have that memorized. I don't do math that quickly. Go up to high altitude. Let's say we're at 600 millimeters of mercury total. There's less pressure. Up at high altitude. So this one is 126 millimeters of mercury. It's lower, right? That's the point. It's going to be harder to get oxygen. This, just at a given, if you just travel up to this level without acclimatizing, there's going to be fewer oxygen molecules available for hemoglobin. Hard to saturate hemoglobins. If you remember, you actually only are using about a quarter of them at rest. So this isn't really that big a deal. You can basically regulate this. Your body's going to be unloading a larger percent of your hemoglobins. So your curve, you're going to be going down lower in that hemoglobin saturation curve. You're going to be moving down instead of at rest being here, you're going to be like down here. So that's fine. It's when you start exercising as well and you're not used to this, that can be a problem then, right? You don't have that same extra oxygen to unload if you start exercising at high altitude. And so this is where it can cause problems, acute exposure to high altitude. Over time, you can acclimate. So how does your body acclimate? It can actually, well, EPO, erythropoietin, is produced, is stimulated at high altitude and will make more red blood cells. Then you got more hemoglobin total, and then you're good.